Hi everyone, my name is Alima and today we'll talk about the lines of charge. Here's the table of content. So from the previous lab, we tried to approximate the charge on a piece of tape, and for that we assumed that each tape was considered at a point of charge. In this experiment, we will consider the tape as line of charges, and we use the principle of superposition to find the electric field over all the divided segments and integrate it. We assume that each tape has the same net force because they were charged the same way, and that each tape was treated as a line of charge. Here the material that was used, like in the precedent lab. Here are the steps that we used to charge the tape, like in the previous experiment. Like shown in the previous experiment, we observed that the charge tape was attracted to my hand and book. The charge tape was also attracted to a pen, and two charge tapes were repelling each other when brought next to each other. So from the experiment, it was deduced that the tapes was positively charged. So for the floating experiment, instead of considering the tape as single charges, we consider them as line of charge, and we can see in yellow arrows the electric field exerted by tape A on tape B. Tape B started floating at D equal 0.3 meters, 0.03 meters. From the previous experiment, we calculated that the charge on the tape was 1.410 to the minus 8 coulomb. When using Python for our program, we set the constants and we created a code to calculate the electric field on tape A. As you can see on the image, the right charge that allowed us to have an equilibrium between the electric force and the gravitational force was 0.8910 to the minus 8. Here, another screenshot of the simulation where we can see the electric field toward the tape and the electric force and the gravitational force almost at equilibrium. To conclude, there was a transfer of electrons between the two tapes when ripped from one another. The tape could have been positively or negatively charged depending on the electron transfer. The charge that a 20 centimeter long and 4.8 centimeter wide piece of tape had was 1.410 to the minus 8 coulomb when we assumed that it was a point of charge. When we assumed that the charge was a line instead of a point, the charge value was 0.8910 to the minus 8 coulomb. The value differs because the charge is evenly distributed throughout the tape and not concentrated in one single point. This experiment is much closer to the reality because it takes in consideration the surface area of the tape. Thank you.